Hiç bilmiyorsun. Hiç bilmiyorsun. Hiç bilmiyorsun. Hiç bilmiyorsun. Hiç bilmiyorsun.
Okay. Thank you, Dr. Atif. According to this scenario, which its part within the human body is very important.
Hiç bilmiyorsun.
We have previous discussion before. If you remember, Dr. Atif, what is the region? Dr. Atif, the most famous one, scenario, which its part within the human body is very important. If you can remember, we have previous discussion before. Previous study, if you remember, that is related to this area. From this one and that one, the most famous scenario, which is part within the human body is very scenario. If you can remember, we have previous discussion before. Previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous discussion before. Previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous discussion before. Previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous discussion before. Previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. If you can remember, we have previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the difference in meaning previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. Remember that? Previous study, this is what that is related to this area. From this one and that one, the most famous method to visualize the results the human body of the scenario. Remember that? Correct?
Okay, everybody. Um, we've ended this session because of the time, and next session will be with face recognition security against deep fakes by using multi-model detection survey by Fatma Al-Qattan, Rahma.
السلام عليكم.
أهلا وسهلا. السلام. حياك الله. Okay, Rahma?
Yes, we are ready.
Okay. You can start now. sorry Rahma. لو ممكن مثلا تلبس.
Hello. Can you hear us?
Yes.
Can you check like if there is an electronic devices nearby you because there is a voice echo?
Okay. Just 1 minute.
Yeah, can you speak now? Dr. Rahma.
Just 1 minute, please. We are trying to share the screen.
No, it's okay now.
Okay, you know. Okay.
There's electronic device. That's what they're saying.
كيف الآن تمام؟ Is it shared?
Not shared yet. Yes, shared.
Okay.
Yeah, we can see your slide, but take all the electronic devices far away from your laptop
Okay.
because there is an echo from your side.
Still there's an echo?
Yeah, still like there is a voice, like you have electronic devices that like nearby you there.
Okay.
Like some mobile phones are there nearby you.
Can you hear an echo right now? Hello?
Yes, yes, go ahead.
Okay. So good morning, everyone. Thank you for having us today. My name is Rahma. Our paper research is titled of Face Recognition, Security Against Deepfakes by Using Multimodal Detection. We are going to start discussing the role of artificial intelligence in facial recognition, its applications, and the security challenges it faces. Starting with artificial intelligence, it does plays a crucial role in modern facial recognition systems, enabling machines to analyze and interpret facial features with high accuracy. Deep learning models process vast amounts of facial data, allowing systems to differentiate between real and fake identities. And as these models continuously learn from yet new data sets, they become more reliable and robust over time. The facial recognition technology works through main steps. The first step is feature extraction, and the second step is pattern classification. The feature extraction by identifying the key facial landmarks, such as the distance between the eyes, the nose shape, and the jawline. While the pattern classification, it works by matching the extracted features to verify an individual's identity. So with the advancements in deep learning, these systems now can handle variations in lighting, age, and facial expressions, making them essential for applications such as mobile authentications. And despite the advancements, facial recognition faces significant security threats, particularly in face spoofing, where attackers use fraudulent inputs to bypass the systems. These attacks can fall into three main categories, as it's shown here in our presentations. The photo attacks by presenting a printed or digital images to imitate the real the real picture of the person, while video attacks by using a pre-recorded video, and the mask attacks by employing 3D masks made of silicone, paper, or plastics. Such threats highlight the need of robust anti-spoofing techniques that can detect and prevent fraudulent accesses, ensuring the security and reliability of facial recognition systems. So AI-driven facial recognition has transformed security applications, but spoofing threats remain a critical challenge. And by leveraging advanced AI models and anti-spoofing measures, we can enhance the effectiveness of these systems and ensure stronger protections against fraudulent accesses. Now my colleague Fatma will continue presenting and discussing our presentation. Thank you.
Greetings all, this is Fatma Al-Nasser. I'm gonna continue. Since facial recognition technology relies on advanced algorithms to improve accuracy and prevent spoofing attacks, so the technology is convolutional neural network, in short is CNN, are a specialized type of artificial neural network used in image processing and facial recognition. Advanced CNN model is improved accuracy of facial recognitions by detecting differences in facial textures, expression, and structure, making them essentially for RAPSET anti-spoofing solutions. CNN consists of multiple layers. Introducing the first layer is convolution layer, essentially enable the network to automatically and effectively extract key features from the input images such as edges, textures, and colors, as I said before. So moving to the next layer, which is pooling layer, it decreases the computational load and memory requirement for processing while holding the most important features. Moving to the third, fully connected layer, is the layer responsible for taking these high-level features and flattens them into a one-dimensional vector. Moving to the last softmax layer, which converts the output of the network into a probability distribution, making the final prediction usable and recognition task. Next, I would like to present related recent work we have been through in face spoofing field since it became a major security concerns are listed as one of the most dangerous AI threats. I'm going to comparing which method models used by which database to present results at accuracy. Starting with the first study, author used modified CNN wavelet CNN, which allows them to prefer better than convolutional CNN when managing high-frequency noise and variation in light, result in less memory usage and faster computation. As you see, accuracy is scored at 99.78, sorry. Moving to the second study, they used 15.6K makeup images dataset, which is divided into 3 categories: tested, validation, and training. Then the data pre-processing and augmentation achieves accuracy at almost 97. For the last 2 studies, we noticed that they have used the same method for the same database, but resulted at different accuracy rate, and that due to using swapping method. In the third study, the swapping face videos by other person faces used by face swap and face shifter and deep fakes. While the last study used face swapping through purposes and biometric conversion of eyebrow area with the rest of person's face, using SqueezeNet, LightNet, ResNet, and lastly, DeskNet. For the rest of the presentation, I will let my colleague Fatma to continue the presentation.
Hi, this is Fatma Al-Gattan. I will continue with you for the CNN algorithms. The facial recognition technology is a system that relies on advanced algorithms to improve accuracy and prevent spoofing attacks. Based on that, we discussed different studies on the most popular deep learning models that reach the most reliable and secure model for surveillance system. First, the ShovelNet, which is a lightweight model designed for mobile surfaces like smartphones, meaning that it can work smoothly even with the limited resources devices. Second, the Inception version 3, which is a deep convolution neural network architecture developed by Google. It's improved version on the earlier Inception model. Third, the ResNet 50, introduced by Microsoft in 2015 as part of the ResNet family. It's designed to solve the vanishing gradient problem in deep networks. Here, going to this comparison. In real life, when selecting a CNN model for surveillance system, several factors must be considered, including security, speed, and computational efficiency. Surveillance applications require efficient resources usage and high accuracy for identifying faces and security footage and prevent spoofing attacks. So based on the recent studies, we compared the three models in this table, which are the ResNet 50, Inception, Virgin 3, and ShovelNet, to determine which is the most suitable for such a system. For the performance, first row, the ResNet 50 offers a high accuracy by addressing the deep learning challenges, like the vanishing gradient problem, while the Inception Virgin 3 is more effective for handling the complex images and varying lighting conditions, which is a common in surveillance settings. ShovelNet, on the other hand, prioritizing the efficiency and the speed, but it's not matching with the accuracy for the other two models, making it less suitable for the surveillance tasks. For the complexity, the ResNet, here you can see it's the second row. In the complexity, you can observe that the ResNet 50 has a well-balanced architecture with a moderate level of complexity. For the Inception Virgin 3 uses a parallel convolutions with the multiple kernel sizes, allowing it to analyze the images at different scales. This increases the complexity, but also improves the feature extraction, which is beneficial for the surveillance footage with the challenging perspectives. The ShovelNet at the last is the least complex, designed for the mobile, because it's designed for the mobile services and the embedded systems with limited processing power. For the computational resources, Inception Virgin 3, due to its complex design, as we said before, requires more computational resources than the other two models, but provides an advantage in difficult lighting conditions. For the speed, ShovelNet is the fastest of the three models. It's an ideal for the applications with minimal computational resources, while the Inception Virgin 3 is slightly slower, but it's providing a more detailed analysis. For the memory, ResNet 50 uses less memory than the Inception Virgin 3. Then the Inception Virgin 3 needs more storage, but provides better recognition for the face recognition system, of course. Moving on to this study result. Following the next table, this table compares two pre-trained versus randomly initialized weights, impact on the Inception Virgin 3 and the ResNet 50 models. It also looks at the training-only dense layers versus all layers trained, showing difference in learning rates, training accuracy, and testing accuracy. For the ShovelNet, the ShovelNet, as you can see or observe here in the table, it's not included as before because it's designed for the lightweight applications such as mobile and embedded systems, as we mentioned before. For the Inception Virgin 3 with ImageNet weights and only dense layers trained has the highest test accuracy, scoring 96.13%, while the ResNet 50, even with all layers trained, performs slightly lower than the Inception Virgin 3 on the same dataset. In conclusion, to summarize, we compared different three CNN architectures, highlighting their strengths and the trade-offs. Inception Virgin 3 demonstrated the highest accuracy by 96.13%, making it the strong candidate for the AI-driven surveillance for spoofing attacks. It also can work in changing light conditions and different angles, which is common in surveillance face recognition in images. On the other hand, the ResNet 50 also showed a solid performance, while the ShovelNet remains an efficient choice for resource-limited applications. In security and surveillance, accuracy and efficiency are critical. Choosing the right model can enhance threat detection and overall system reliability. As the AI continues to evolve, optimizing deep learning models for security application will remain a key focus. Thank you for your time and attention. I hope this presentation provided a valuable insight into how AI models can enhance surveillance technology. If you have any questions or thoughts, we would happy to discuss them with you. Thank you.
Hello. I think same. Is it better? Any question? تفضل دكتور.
Facial anti-spoofing area is, I think, it's new since 5 years, last 5 years. I think the paper has not covered all the research works. There's some research work by Mafisa or some in Coulter, and also other works, and it should enrich basically the paper, the more not only just classifiers, the specifically the methodologies, because many the papers I have read, they put too many descriptions or describing their methodology. So I think they should enrich this paper. Thank you.
For that point, we have summarized and studied 8 researches, 8 related works, but we choose to represent in this presentation the most for recently that published. Is my answers clear, or do I need to repeat my answer, or I'm not answering your point?
And terrible Arabic hate speech detecting using large language mode. If the author of this paper is available, you can start. I have the group names Majid, Ibrahim, Hassan.
Yeah, I am here.
Okay.
Will you share now?
Yes, please.
It's clear now? Okay, Assalamu alaikum. My name is Ibrahim Gad, Faculty of Science, Tanta University, Egypt. My title paper is Arabic hate speech detection using large language model. Our content is, it will be introduction, then the proposed method, experimental result, conclusion, and references. First of all, now, because of social media platforms serve as a space for users, they can express their opinion and they make discussion. This social media has freedom of expression and maybe lead to increase in hate speech, especially in Arabic community in our area, especially in the Middle East. Also, there exist many platforms such as Facebook, Twitter, and many other platforms. These platforms, they don't have, they don't have any control. So maybe there exist many report of occurrence of hate speech. Hate speech is especially, we can define it as a language that dominates or indicates violence against the individuals or groups based on attributes such as race or ethnicity, religion, gender, and so on. Also, we have the growing number of online platforms increased the visibility and effect of hate speech. Especially, we don't have control in this special platforms such as Facebook or Twitter. Nowadays, because of our area have many different age or races. Also, this have to increased influence. This is other problem. In our area, there are more than 20 million native Arabic speakers, making it one of the most popular language used online. Also, Arabic language is rich of morphological language with a variety of delicates, each with different grammar and lexical features. One of the most challenging in Arabic language is Arabic sentence. It can have different meaning depending on the context, and also the tone and even cultural difference. As you know, in Saudi Arabia, sometimes we have different keywords. In Egypt, we have another meaning. This is also a challenge for another challenge. Arabic is not used enough in the development of natural language processing tools, especially in the hate speech detection. Nowadays, as we know, there are many advanced large language models such as ChatGPT, BERT, and DeepSeek that are used for many classification tasks or hate speech detections. The application of these models to Arabic remains a challenge due to another challenge, I mean limited availability of Arabic hate speech detections or annotated dataset. Also, how to explain the output or results of these models is still challenge because as we know, the Arabic language have many different language for one sentence. This is another challenge also in the platform. So in our model, we used large language model such as Arabic BERT to detect the hate speech in our platforms such as Twitter or X now. We collected dataset from X and used the expert from Arabic people to notate it. So we used this model to use for our task. The simple steps of our model, actually, we used the Arabic dataset collected from X, is annotated by a human expert. Then we used the Python tools, for example, to remove null data. Sometimes after and label this data, there exists many null row, or empty. Then we use word embedding and also count factorize. Also, we have to tokenize this dataset. After cleaning the dataset, we used splitting function. For example, 70% of our dataset for training, 30% for testing. Because as we know, are limited resources. We have only less than 5K of rows in our dataset. We use Arabic BERT, the large language model, in our method. Finally, we used the XAI to explain the output of this method or platform. The distribution of our dataset, actually, we have 3 classes: normal, abuse, hate. The total number of rows actually is less than 5,000 rows. This is our dataset description. Example of our dataset, as you know, the tweet in the left in Arabic language, in the right class or label for each row also. First, we used simple machine learning language for this task. We used many machine learning models. It was not good. Actually, the best one, it was linear subperfect machine. It was almost 80% for accuracy, also precision and recall metrics. When using in 1 gram, it was 1 word for each task. For Arabic BERT, we have increased our accuracy a little bit more than 80%. It's better than the machine learning language models. In table 4 or 5, 6 also, sorry, it was the browse model, now accuracy 84%. While linear subperfect machine, normal machine learning, it was less than 80%. Figure 5 explain how the model use XI to explain the output of it. For example, read words, it was the model detect it as not good words or something. It explain how the model see the result of it. Conclusion. In this work, we're using simple machine learning models and also large language models to detect hate speech in Arabic language. We have many problems in this model. Actually, the accuracy of the model is not good, but we're trying using machine learning model and the Arabic BERT to increase the accuracy. In future work, we can use ChatGPT or DeepSeek to increase the accuracy and explain how the model see each word independently. Also, we can use optimizer or another parallel processing or the federal learning and they collect many dataset or merge Arabic dataset from different countries to increase the accuracy in our model. This is the references. Thank you. Any questions?
Thank you for your presentation. I would like to ask about the data sets, where they are from, and any details about these data sets.
Actually, it was collected since 2 years ago. It was from Twitter before they changed the name of X. I collected and I think from Saudi Arabia accounts. I have friends from another college. They helped me to collect it. We labeled it using human meaning. I mean, this is collected by human and also labeled by human, not another tools. Actually, we have faced many problems in label it because, as you know, different delegates and also different meaning for each word. This is another challenge in our label.
Was done by the researchers themselves, or did you ask workers and people to label it for you?
No, our teams, it was all researchers and professors in college.
Okay, thank you.
Thank you.
I would like to of this presentation to introduce artificial intelligence model to that used for detecting the unattended luggage.
localization of the software.
The purpose of this presentation to introduce artificial intelligence model for detecting the unattended luggage. Yeah, for unattended luggage. By using surveillance cameras in the public places, for example, airport or train station and other places. And the reason of that, and the reason of this project, or the purpose of this project, to enhance the security of these places, because the unattended luggage, it may contain a dangerous stuff that threat people's safety. So the model will inform the security of surveillance cameras to then the security will take the necessary actions to deal with this unattended luggage and take out of this place. The project objective, the first one is to develop object detection algorithms that have high accuracy, and the second one is make a relationship between the luggage and its owner, and the third one is reduce the false positive and false negative detection, and the last one is detecting an unattended luggage in real time. This is the fourth objective. This is the literature review or the related work that we gained the insight from them. The first project is called Abandoned Object Detection in Surveillance Systems, and the second one is Object Detection Models, and the third project is called Proximity Analysis and Re-Identification in Object Detection, and the fourth one is the detection of unattended objects in crowded environments. This table is the summary of these four projects. We mentioned the author names and the method names and method description and case study availability if it's available in public, and the data set that they used it, data set name and the data set description, and if it's available to the public, yes or no. And the last one is food availability, if it is available to in public or not. This is the summary of these related works. The tool we use in our project, the first tool is Python. The Python is the programming language that we used it. And the second one is Google Colab. It's a website from Google that we used it to train our model using a data set. And the third one is OpenCV. It's a library for computer vision. We used it to draw a bounding box around the object and the line between the luggage and its owner. And the fourth one is YOLO version 8. YOLO version 8 is the object detection. YOLO version 8 is object detection that we use it for this project. And the last tool is called Skinter. Skinter is the library for creating a simple user interface using a Python. The data set that we use it to train our model is contain above 7,000 images that classify to 4 classes. The first class is the person, is the person class, and the second one is the handbag, and the third class is suitcase for traveling, and the last one is the backpack. The backpack. This is the classes. How many classes? Four classes. Yeah. The model can detect 4 classes: person, handbag, suitcase, backpack. This is the system architecture. It may take some time. Can I? This is the system architecture. We represented in this flowchart diagram. The first thing is happening. We load the YOLO, then we initialize the video stream, then we start to read the frame. After reading the frame, the YOLO will start to detect the object, and we will go to this function that is called check proximity. This check proximity will classify the person and the luggage, and it will store the luggage boxes to this loop. This loop will compare the luggages to the person to see if this luggage is unattended or not. This is the summary of this loop. After the loop ends, it will return the frame. Then it will display the frame. Then it will start to read the next frame, and it will continue in this function. This is the user interface design. As we can see, the first thing is the video path. You can write the video path if you want to processing a video, and if you want to use a camera, that is connected to your personal computer, you can write in this text box number 0. Number 0, it means source 0. Source 0 is the camera. It will run the camera that is connected to your personal computer. Okay. Yeah. Next. The second one, you here write the model names that using for detection, and the device you can choose CPU or GPU if you want to processing the video, and this is the detection confidence. You can assign the detection confidence for the model. If the model is its confidence is 0.5 or more, for example, it will detect it and draw a bounding box. And if it's below the 0.5, it will ignore the object. And the last thing is the threshold. The threshold is the distance between the luggage and its owner. We assign this number 150. If the distance between the luggage and person is more than 150 pixels, it will consider that the luggage is unattended. This is some results, as you can see. the person, the bounding, the red bounding box is the person who left his luggage. Yeah. Yeah. And the yellow bounding box is the unattended luggage. And the line between them is the relationship or the distance between the luggage and its owner. We tested 4 videos, video 1 and video 2 and video 3 and video 4, using the models. These are the descriptions for each videos. This is the evaluation metrics. As we say, we tested 4 videos using 3 models. The first model is our YouTube version 8R. This is the model that we trained. And the second model is called Universion 8N and Universion 8X. These two models are pre-trained models. We extract the result, the accuracy, and the precision, and recall and sequence scores. This is the confusion matrix. As we said before, we tested 4 videos to these 3 models, and the meaning of these, the person versus person, it means how many persons that the model that is considered as a person. How many persons considered as a person? Yes, for example, 39 times. And this is how many persons that considered as suitcase. 0. And this is how many suitcase that considered as a person. 7 times. This is how many suitcase that considered as suitcase. 5 times. By the way, the prediction confidence is 0 in the evaluation metrics and the confusion matrix. This is some challenges that we face them. The challenges we face. The first challenge that the model sometimes distinguish between the real owner of the luggage and people nearby the luggage. As you can see, this person as the luggage owner, but he is not the real owner. The real owner is this way. This person is nearby the luggage. So the model thinks so that he is the real owner. This is some challenge that we face. And the proposed solution for this problem is using re-identification. Re-identification is a technology that saves the person function. So the model can recognize this person from many videos and from many cameras. And the second challenge we face that the model sometimes doesn't detect a luggage because it's small scale, and because the low lighting and maybe because the camera angle. So the model doesn't detect this luggage. So the proposed solution for this challenge is fine-tuning the luggage, fine-tuning the model by training this model to using a data that have a similar object and similar environment. This is the recommendation for future work. The first thing is the integration, the re-identification. The identification, we explained it before. And the second thing is advanced object tracking and behavior analysis. And the second future work, inshallah, is AI-driven threat prediction. And the fourth one is improved false positive reduction. This is demo. Results from one of the tested video. As you can see, there's the bounding box of the person and luggage. When the person left his luggage, the person became yellow. And the Our system used the Euro version 8.
Doctors, can you mute yourself, please? Doctors.
Sorry for interruption.